Hello, hello. So, Internet, welcome back to this thing that I'm doing. So it's been a while. It's been maybe, I don't know, 5, 6 weeks since I made a video. And the reason being is I've gone on a bit of an escapade and I dove into infrastructure as code, specifically Terraform. And then from that, after doing a week and a half or 2 weeks of that, I kind of, on the spur of the moment, decided to pursue certification, specifically in DevSecOps, which is in relation to Terraform and infrastructure as code. So I've been doing that, and I got my certification, which is cool. I got it in 3 weeks, and I wanted to basically walk you through my process, some of the things that I'm going to take forward with me from this DevSecOps certification, and some of the concepts that jumped out to me that I'll probably remember for a while. So with that being said, I'm going to shift this back to this screen. And as you can see here, I have basically written a post, and this post is a lot of what I'm going to discuss today. I have a series of tabs open, so I have a bunch of graphics and images and things like that so that I can hopefully help you understand what I'm speaking to when it comes to the more nitty-gritty things. But at a high level, I kind of just want to walk you through my journey to pursue the certification and some of the things that I learned from it. So with that being said, let's get it started in here. All right, so first things first, I broke this into 3 sections. So it's the why. So why did I pursue the certification or any certification? The next part is I think it's the how. So how did I actually approach this learning process? Due to the fact that I've finished it faster than most, at least from my experience. And then the last part is what. So what are the main concepts that I took away from this process and this kind of the certification curriculum? All right, so we will start with the why. I'm actually probably going to skim over this because I've touched on it into here, but really the premise of this is that I'm not a huge fan of certifications, but with that being said, there is some credibility that comes with it, especially when trying to basically break through barriers of HR. But in a nutshell, certifications are nice. The really reason I pursued this specific certification is structure. So DevOps and DevSecOps is a very, very large kind of amalgamation of topics, and it's sometimes hard to synthesize or cohesively connect all these different things together into a single narrative that someone then can consume and learn from. So I wanted to find something that had structure. But also another really important point that I want to mention here is actually following the puck. So we're going to draw because we love to draw. And I hope this color is good enough. Yeah. So you can see I've mentioned here, follow the puck. So this is a concept that I broke down and kind of touched on in here. But if you come down here, I'll kind of explain it through this graph. So when working with clients, I'm in a unique position to actually interact with a lot of different clients from different industries, different maturity levels for their security program, and also kind of just different know-how of different aspects. And I kind of bucket clients into what you can see here. And this is a common thing that a lot of people talk about, where you have the early adopters, late majority, laggards, etc. And in the ethos of information security and specifically DevOps, I realized that I would say the laggards, a portion of my clients, they are currently going through the process of deciding to migrate to the cloud, or they're currently migrating to the cloud. So those are, I would say, both the late majority and the laggards. But I do have some clients that are in the early majority and early adopter section. And they're actually taking more advanced steps where they're already in the cloud and they're actually breaking out into microservices, and they're actually starting to work towards serverless architectures with functions. And they're actually doing a lot of engineering as security teams to kind of embed, bake in, or burn security into the left-hand side of this whole process, so the developers are enabled to be more secure without actually getting in their way. So I thought that was super interesting, and I decided to kind of pursue it for that reason, because I see that a lot of these early adopters and early majority, they tend to lead the way, especially the big tech firms, big tech companies. They lead the way for a lot of the other companies. So I figured if I focused on that area of learning more about the somewhat newer things that are upcoming for the large majority, then I would be in a better space for the supply and demand of talent and economics and all that stuff. So try to be recession proof is the lesson there. So with that being said, that's kind of the first piece. The second piece I wanted to jump into, and actually I'll talk about this too. So this piece I mentioned here was that my approach to learning new things that I've just explained is very non-sexy to someone that's really bought into follow your passion, follow the thing that you love, pursue that thing that you enjoy. For me, I don't have a passion. And sadly, I know a lot of people don't have that. They don't have like a singular thing that they want to pursue for the rest of their lives. And the majority of us are in that bucket. So through a series of books from Cal Newport and a series of other authors, I've kind of came to the conclusion that for me specifically what works and what I really find value in and I enjoy is taking these three circles, right? So you have your interests. So this is a really important one. So ensuring that whatever you're pursuing to learn, you have to be interested in it. So interest is key. The next thing is, where do you have skills currently or your previous experience that then applies to this? And then also a really important part that people don't necessarily look into is actually the opportunity. So this is basically saying in the market today, the economy that we sit within today, what are the skills that are most sought after and then which ones are paid the highest basically. And if you look at that, you'll start to see that a lot of tech jobs are obviously being highly paid. And when I say tech, I'm talking about architects, developers, things like that. And there are a series of other industries and areas that are being paid highly. But for my purposes here, I realized that kind of taking all these things and putting them together, this curriculum and this certification kind of fell into that circle there for basically pursuing this specific certification because of the curriculum and the data and the topics inside of it. So that's kind of the why. The next is how do I do this? And this section is very short. Reason being is I've actually already written a post on this, so you can see it's linked here. And this is basically my journey into getting the Sec Plus. So this is when I first started getting into security, or at least getting serious about it. And I was fortunate enough to actually pass the Security Plus in 2 weeks. And I walked through kind of in depth my process of how I kind of accelerated that learning journey. Instead of taking 2 or 3 months, I kind of condensed that down. And in here, I specifically wanted to touch on some of the differences because when I pursued the Security Plus, I had full time to work on it. So I could do 24/7 all the time Security Plus content. But now that I have a full-time job, I don't have that luxury. So I have to do evenings and mornings mainly to focus that time and that energy. So specifically with this one, I kind of summarized some of that and touched on it. So I'll point out a few areas that are somewhat new to my accelerated learning process for this. So to kind of take you through it, every single evening I would dedicate 1.5 hours to 2 hours to reading, watching videos, or working on labs. And then in the mornings, if I had time, I would read. So that's kind of like the structure of how I would set it up. And those were the kind of the guardrails or the barriers that I wanted to make sure I stuck within. Another really important thing with this curriculum, and really any curriculum that's as broad as DevSecOps, is you have to be very focused and somewhat essential with how you kind of give your attention to certain topics. Because I found myself in the very beginning of this process falling off and diving deep into topics that were relevant and related, but not directly correlated to the exam that I was eventually going to take. So the key here is actually to be very essential with your attention and focus on what matters. And there's a book here that's really good called Essentialism. If you've not read it, you should read it. So that was kind of the focus, right? So being essential with my time and my attention, but really focusing on what I knew would be on the test. And I knew it was on the test because there was quizzes at the end of each section, and there was 2 practice tests I had access to. So by taking those exams and taking those quizzes, I knew that there's certain subsets of this data that's going to matter more than others. And that's mainly the stuff in the slides and the notes. So that was kind of the accelerated learning piece. So now we're going to get into the meat of it, right? So I broke out some of the main concepts that I took with me from this, and this isn't everything. So there's like hundreds and hundreds of pages inside of this course and this curriculum, so I'm not going to cover it all here. And I can't do that because it's kind of like I would get in trouble. So what I've done is I've kind of taken concepts, ideas, and higher level ideas and technical topics that I think that I will carry forward that were new to me or unique. So first things first is we're going to start with the mindset. So this sounds kind of fluffy and not technical at all because that's true. But this is probably one of the most important pieces of really doing DevOps at any way, in shape or in form, or DevSecOps. And the reason that this is so important, and you'll see that there's a lot of people that talk about this that have done it for a long time, is with DevOps specifically, it's less of a process and less of kind of just a technology or a series of technologies, but it's more of a cultural change, which, like I said, sounds cheeky, but it's really important to understand that if you have not adjusted the culture to fit inside of something that's driven this way, then you'll never succeed. You'll never get to the point where you want to be when it comes to this kind of stuff. So I wanted to share some interesting resources and things that I found useful. So first things first, this talk here So Netflix is pretty popular in the DevOps space, specifically with microservices. And here, this is probably one of my favorite topics from a Netflix engineer. This guy, I think his name's Dave. Yeah, Dave Ham. So he and a series of other Netflix engineers do a lot of talks, and I've watched probably not all of them, but a crap ton of them. And his is probably one of my favorite because he talks about not just DevOps, but security as well, and the importance of actually not necessarily getting in the way of the engineers, but actually enabling them, and not setting in controls, but getting more context. So it's very counterintuitive to what a lot of information security culture has been historically, and they're fundamentally trying to change that and being enablers instead of basically gatekeepers. So this is a good talk you should check out. In addition to that, I wanted to share some diagrams. So this diagram here is a common diagram that you'll see when someone talks about DevOps, right? So it's kind of like an infinity loop, and things feed back into each other, and it's a snake eating itself. And specifically with this, we can walk through some of these. I'm not going to walk through everything, but as you can see, in the first phase, you plan, code, build, test. You release that, you deploy, operate, monitor, and this all feeds back into itself as you keep going through it. This here has a series of security oriented concepts inside of surrounding DevSecOps here, or DevOps. So some of the stuff in this curriculum that was really pointed out quite frequently was code analysis. So being able to actually have plugins into the IDE for the developer, so when they're coding, they're actually doing security on the fly. So if they're typing in things that aren't necessarily as secure as alternative options for functions or evaluation strings, etc., those plugins can help there within the IDE. Another thing before that planning is obviously threat modeling. So thinking through different types of threats that are big concerns and risk modeling. So some other stuff here, code analysis. So this is a series of acronyms. So there's dynamic application security testing, I think, is DAST, SAST, which is static analysis. And then there's IAST and RASP and all this shit. But really, this part here is going to be focused on static analysis because you have your code, you've written it, so it's going to analyze the code statically as it's sitting there not doing anything. As we go through here, you can see there's another part of code analysis, and this is dynamic analysis. So you're actually going to deploy it, and you're going to dynamically analyze this application as it's running. So that manifests in many different ways. These tests can be smoke tests, so you're kind of just going to try to basically start a fire, and if you see smoke, then it's no bueno. There's also fuzzing and a series of other tests. So you're actually really testing this code as it goes from being analyzed via static into a runtime kind of test. And there's a whole bunch of other stuff here, but I'll leave that be for now. So that's the first one I wanted to show you. There's another diagram I have here that's a little bit more robust and it has more information in it. So this is probably one of the better ones that I found that actually talks through some of the stuff, but it's kind of convoluted because not all the diagrams are one for one. But for this one specifically, we can point out a few things. So this planning phase is very similar to the other one. So as I mentioned, there's threat modeling. Metrics is very important as well. We'll talk about that later. So that's some of the stuff there. So that's the plan phase. The IDE plugins I've talked to you already about. Here's all the acronyms that are the acronym soup. So we have SAS, DAS, IAST, SEA. We've not talked about SEA. So SEA is software composition analysis. So it's basically looking at your associated libraries and plugins that are being pulled into the code and checking for vulnerabilities for those. So you have basically a database of vulnerabilities you're pulling in and validating and seeing if in your code there are different vulnerabilities that are known for the plugins or third parties that you're using. So that was that. So fuzzing we've talked about. Integration testing. So going through this when you're kind of releasing code, in addition to testing it dynamically and statically, there's an integration test. So there's unit tests and integration tests. Integration tests are basically looking at specifically all these different pieces inside of this application. When they interact with each other, are there flaws or vulnerabilities that we can discover as they're interacting instead of just siloed off entities in themselves? And this is where kind of the study of complexity comes into place, and it just really gets crazy. Chaos engineering, which is really cool. So this is Chaos Monkey from, I think this is Netflix. So they kind of popularized the concept of chaos engineering. We're actually trying to break things and seeing how both operations and security react. So that's more kind of on the advanced end of things. So some other stuff. So RASP is added to the acronym list, which is runtime something something. So inside of the application as it's running, there's actually kind of a RASP tool that can be embedded inside of the application as it runs. So it's not necessarily like a web application firewall where it's out on the perimeter, but it's actually embedded in with the application to test for different types of baddies doing bad things. So we'll talk about the API gateway in a bit. We won't talk about orchestration much, but I will touch on this briefly. So orchestration, so we have containers in Docker, and containers are a phenomenon that everybody's jumping on board with. And specifically with containers, as you start to use more containers and they start to interact with each other, you need some sort of orchestration layer on top of those containers to actually understand who's talking to who's siloed off from who, what data is being exchanged, who has access to what, all this stuff. And that orchestration layer is usually Kubernetes. So that's kind of one of the really important pieces in there as well, as they'll talk about within DevOps and DevSecOps. And I think we'll stop there because that was a lot of time. So this is another diagram that kind of walks you through it, and I thought that was kind of interesting to learn more about that. So that was DevOps, right? So the next thing I have here, in addition to the mindset, is codifying all the things. So what do I mean by this? Within this course and a lot of the things you research around DevOps and DevSecOps is you'll realize that the security role is turning into an engineering role. And you're not necessarily engineering applications and building things in JavaScript, Node.js, and things like that, or .NET, but really you're focusing on YAML files. YAML files and things like YAML files. And a YAML file is basically a declarative language that a lot of infrastructure as code tools use, and also configuration as code and all these other things, where you can actually use things like Terraform to actually build out your infrastructure in an automated fashion with a series of checks inside of it as it's being deployed. So you're basically codifying all the manual steps that a lot of operations and security teams used to take into basically a simplified script, a declarative language, and that then goes and does all the steps automatically. And there's a million different reasons why this is useful. I'm not going to kind of dive into it all today, but really the main ones are you remove the human. So that's you're going to have less vulnerabilities and less mistakes, but also you have an audit trail. So it's very auditable because you've tracked all the changes that have occurred to this infrastructure over time through this file, and you've also ensured you knew who did what at all times. So this is actually very useful for auditing as well. So some things I had here for YAML engineering is this simple diagram here that walks you through the difference, because there's imperative languages and there's declarative languages. I think Ansible is another configuration tool that has a declarative language or imperative language. Terraform is the declarative, which most are declarative. And the difference between the two you can kind of see here. So here we have basically a simple understanding of, we have explicit instructions for imperative. So it's basically saying that I'm going to walk this machine through every step I want it to take without really telling it what I want it to do. But I'm saying, like, go here and then go here, do this, go here, do this, go here. And you're kind of walking them through the steps. Declarative is basically saying, this is what I want, you figure it out. And that's kind of really the big difference between those two. You can obviously go as deep as you want on that. I was kind of fortunate with this section of the discussion, mainly due to the fact that I've had some experience with declarative languages with Terraform, because as I told you earlier, I've kind of read through a lot of the Terraform stuff. Specifically, this course was useful for me. Terraform, on their website, they have like a learning university that actually walks you through a lot of their Terraform language, and you can kind of go through this entire thing, because I think they have their own certification you can kind of apply for. But this was very useful. Another thing that I found useful as well is this book. So this book specifically talks to some of the basics that course will talk to, but also this book will talk to how to think about Terraform at scale. And they talk about some of the nuances of when you kind of use Terraform in a production manner instead of just through courses and practice projects. So I thought this was good as well. So the next piece, after we've talked about codifying everything, we're going to move on to version control. So let's zoom in a bit. So this was another really big piece here as well. So version control is kind of at the center of everything with DevOps and DevSecOps, where everything has to go through version control, so then it can all be tracked, so it can all be audited, so everything can be basically checked, validated, reviewed, ensuring that someone that submits something shouldn't be submitting to the wrong branch or have access to the wrong branch when doing so. So that's very key with a lot of this stuff. One specific thing I wanted to show is this diagram kind of gives you a high-level understanding of what version control looks like. Most of it is done through Git, and you'll probably use GitHub or GitLab or Gitbucket, one of those. And if we look at this, you can see the different colorings, right? So we'll start with the master branch. The master branch is the very top. So this is kind of where all of the production code goes. So this is where, the application lives. This is the highest, most important level where very few people should have access to this to submit things. Hotfixes is basically if something breaks and you need to immediately do something with that. And actually, let's change the color. What does that? All right, cool. I think I just did something weird. Okay, no, we're not. We're cool. All right, so hotfixes. So this is, as you would say, a hotfix. So you can see that we have our main line here, and we have a hotfix right here occurring. This hotfix should rarely happen, but that's when you have direct access to the main branch, the master branch. Should rarely happen. So then we have a release. So we have our releases here that are being kind of released from here, but they're being released from the developer branch. So this is where most of the action happens here. A lot of the work is going to occur in the developer branch, and a lot of that work is actually going to, from an individual's perspective, going to happen on feature branches. So these feature branches here in this green section, these, oh my pen, it's not looking good. All right, so this area here, a lot of this section is where I as a developer would work, or myself as a security engineer would work, because you're adding features, you're fixing things, you're doing stuff in this level. Then you're going to push and then eventually commit then push this code into a feature branch. That should then go through a pull request, which basically states that there's somebody that should review my code and review the diff, the change that's occurring there. And after they've reviewed that change, they'll then accept that that request you've asked for, and they'll put that into the feature branch. Once it's there, then there'll be another review. So there's multiple levels of reviews before it actually reaches this very top piece here. Reason being is you want to make sure that you're putting in right code that's not going to break everything, but also you want to check the security aspects of it as well. And there's a lot of security scanning that can occur here, and also security manual code reviews for high risk code, such as things working on encryption and stuff like that. So that's version control, which is very, very important to a lot of this stuff. Here's another simple kind of actually no, this is the next section, sorry. So version control, talked about that. Continuous integration and continuous deployment. Or delivery. So there's a difference here, right? So I don't have an image for this, but I'll briefly explain what it is. So we'll go to pink. So I'll explain the CI/CD piece in a second, but let's focus on the deployment piece here. So there's two different flavors of this. There's continuous deployment and there's continuous delivery. Most people do continuous delivery. Continuous delivery means basically you've gone through all the different steps. Right before you put it into production, there's a manual review process where somebody manually says, like, yes, we can put this in. I'm going to push the button and it's going to go. Continuous deployment is some of the more advanced kind of early adopters where they're deploying right away. So when somebody submits their code, that then merges into the main master branch. Then a whole bunch of things kick off where you're doing a whole bunch of testing and all that stuff. And it's actually automated all the way up to the actual deployment. There is not really a manual gate in between me submitting code and that going up into production. So that's kind of the difference there. And if we go to here, you can see this is a simple flow and a breakdown between let's go to black. All right, so we have continuous integration, which is this section here. And then we have continuous delivery, most likely, or deployment here. And you can see you got your code, you've committed it, so you've committed it to the master branch after it's gone through those layers, and then that's going to then go through an integration process where it's going to do a build of the code, so it's going to take that static code and build it. You're going to have a whole bunch of tests, so that can be unit tests, that can be integration tests, that's going to be a lot of scanning for vulnerabilities both inside of this integration process, but also, remember, inside of our IDE. And there's a lot of other steps in here that's not being shown in the graph, but at a high level, this is kind of what's happening. Some other stuff is high-risk code. So there will be some manual reviews, like I've stated previously, with like code that's doing encryption or things that are dealing with consumer data and things like that. You want to really review that code. Then we have our staging. So that can be staging of images maybe. So we have a series of images that are making up a Docker container that is then deployed. So these images then can be scanned. They can be scanned for vulnerabilities. They can be scanned for library dependencies and stuff like that. And then finally we deploy into production, and that's when you start the monitoring process and all that jazz. So this is kind of the divider line between these two here. This piece here I wanted to show specifically because a lot of this course was focused on Jenkins. And let me do this here. Nope, we want black. All right, so a lot of this course here was focused on Jenkins, and that's mainly due to the fact that a lot of people still use Jenkins. But over time, more and more companies are actually starting to lean harder on GitLab CI and GitHub Actions, mainly due to the fact that the Jenkins piece here has its own server that you have to maintain, and that's more additional work that you have to do of maintaining the server and ensuring that it's safe, secure, up to date, all that stuff. And all these tools here are really mostly continued delivery and continuous delivery and deployment, kind of the CD part of it. And what they're doing here, and you can see it's both CD and CI because obviously GitLab's named CI, but this is an automated way to have a series of events occur throughout the process. So you're kicking off an event and everything is automated up to the point where it's actually deployed into production. So it can either be deployment automated or it can be delivery manual. And all these different event triggerings and all these things that are tied together, these are the tools that you're going to use mainly. Jenkins is kind of like the mother of all, where you're going to use that for a lot of this stuff. But over time, like I said, a lot of people are moving to GitLab CI and GitHub Actions to replace Jenkins because that's managed by GitHub or GitLab. It's a cloud hosted thing, and it's no longer a server I need to do. And this is very similar to the cloud migration that we had many, many years ago, where everybody started migrating to the cloud because they didn't necessarily want to take care of the servers and have a data center. They wanted to do that, give that to the experts and let them do it, and we'll pay them. Similar process here with the CI/CD stuff. This is just an interesting report that I came across when doing research for this, and I wanted to share it with you. So this is InfoQ, so they have a ton of really good presentations and conferences and things like that, but they also write papers. And specifically, this one here is talking through DevOps and Cloud for 2021. They have a graph of the graph that I've shown you previously, just with things mapped over it. I'm not going to touch on everything here because honestly, some of it's new to me. But you can see that the late majority, they're doing a lot of the things that we've already discussed, right? So these are a lot of the things that we discussed or will discuss or was a part of the course. Some of these more advanced things here for the early adopters and innovators, some of this stuff is foreign to me. Like data mesh, I think I kind of maybe know what that is. Policy as code is something that was covered in the course. So that's another interesting thing where you can actually codify a lot of the auditing for your for the policymakers that are kind of reviewing your stuff. But really a lot of the stuff is new, but I wanted to point it out. You can kind of Google this and find where it is, but it kind of gives you an idea of where people are at today and how people are kind of slowly migrating towards new approaches to architecting and doing DevOps. All right, next topic after this CI/CD is authorization and authentication everywhere. So with DevOps and specifically microservices, because microservices was a big part of this curriculum as well, due to the fact that a lot of people that kind of adopt DevOps, they tend to start utilizing microservices due to all the benefits that you get from it, but also there's a lot of complexity that comes with microservices as well. And one of the key points that were made here and other places when it comes to microservices is authorization and authentication kind of become the keystone for security due to the fact that it's not just authentication and authorization on the perimeter to the people entering the network, but it's this whole zero trust concept, which is very cliche and it's very markety, trendy, and a lot of companies use it to sell stuff. But there is a purpose for this, and it's this thing that's existed forever. But zero trust within this kind of context of microservices and DevOps is that not only do the users need to be authenticated and authorized continuously throughout the network, so do the services. So when I say services, the machines are going to be interacting with each other to do certain tasks, and each of those machines have a limited set of permissions. They have a limited set of authentications that they have that are then rotated continuously, and all these interactions are all kind of baked into the infrastructure. So incorporating this correctly is very important for having a secure kind of network when it comes to this stuff. And I did want to share a specific video here that actually talks through OAuth, which is one of the authorization protocols. And you can actually use OpenID Connect, which is a flavor of utilizing OAuth. And that's actually, I talked about here and I linked it here. And that guy right there talks through kind of how you use OpenID Connect. And when I see OpenID Connect, it's referring to when you click a button and it says log in with Google, log in with Facebook, log in with whatever, it's pulling your identity from somewhere else that's trusted, and then it's bringing it back into this other service you're utilizing after you've gotten a token from them. So that's the OAuth piece. Here's another piece that I wanted to talk about. There's a really interesting concept mentioned in the curriculum where it's basically taking your microservices infrastructure and you're actually baking in public cryptography, so PKI infrastructure, into all the services. So all the different machines and all the applications that are interacting with each other, all of them are actually going to have a trusted CA inside of it. They're all going to actually, let me change the color again. So they're all going to have their own trusted CA. So you're going to have like a little repo of who's trusted and who's not. And then they're actually going to pass these certificates back and forth between each other. And those certificates are then going to be authenticated before they can actually interact, because you can see they're going to do the certificates, they're going to share the keys and all that stuff, and then that's when they're going to start sharing the data back and forth. So you're not only going to encrypt and kind of ensure that the data is safe when it goes outside of the network, but also everything that's moving inside of the network is going to be safe as well. So that's a really, really interesting concept that was kind of discussed here when you move to the microservices construct, is ensuring that there's mutual authentication throughout all the services inside the network as well. All right, drink of water. Ooh, it's a marathon. All right. So we've talked about this, authorization, authentication, measuring everything. So I'm going to be quick with this one, mainly because it takes forever for this video. So DevOps is very heavy on metrics. So metrics are everything for DevOps. They have lots of metrics. They try to consume all the data they can. They try to ingest everything, and they try to make valuable, meaningful metrics from that data. And specifically, DevSecOps is kind of following suit with DevOps in many ways. There's many different things that DevSecOps follow suit of DevOps. One of those is metrics, ensuring that you're actually measuring as much as possible and getting value from that measurement that you've made. So here's just an interesting chart that kind of shows you some of the metrics that DevOps uses. Won't talk about everything, but let's talk about, we'll just pick something. So frequency of deployment, change time to failure. Let's do frequency of deployment. So basically, how frequently are you deploying, and how long does that deployment actually take from start to finish? That's one major metric. Mean time to detection and recovery. So this is both security and operations, right? So with DevOps, you want to recover as quickly as possible if something goes down, but also you want to, in security, detect any anomalies or malicious activity that's occurring on the network. So that's kind of a double duo there. So this is an interesting chart. Check it out if you can find it. All right, so here's some metrics in relation to security. I pulled up two websites here. I'm not going to cover all of them, but I wanted to cover two separate parts in each website. That's why I have two websites. So this first one here is interesting. So this is talking about a portion of your apps covered by security. So I'm sure this is interpolated in different ways, but there's one interesting bit about this DevSecOps piece is when you're doing your scanning in the beginning with the static analysis or the dynamic analysis of an application in its code set, is ensuring that you have a high code coverage. So what that means is that when you do your scans, you're scanning the majority of the code. You're not missing out any bits of the code that would be accidentally missed. And this is an issue that happens sometimes with serverless architectures, which we'll talk about in a second. And that's really functions of a service, like where everything is abstracted except for the code itself with your infrastructure. And there's these things called mono repos, and they're basically pulling all the repos together, and that helps you increase that code coverage for that scanning. I said a whole bunch of stuff. If it doesn't make sense, I'm sorry. But I'm just trying to get things out that I thought were useful, and you can Google them later. All right, so that's that. Next piece is, let's go to here. So this section here, I'll just kind of bundle these two together. So discovery of vulns and basically how long it takes you to remediate those. These are two other big metrics that are talked about a lot about within this kind of realm of DevSecOps, is how many vulnerabilities are discovered? Is that going down or up? And if so, why? And then also, when it comes to those being discovered, how early on in that deployment process and that integration process are they being discovered? And then also, in addition to that, how long does it take you to remediate that vulnerability that's discovered? Because one interesting thing is about this metric here is that if you have your pipeline, right, you're going through this and you have your IDE and then your final deployment here, if you can actually discover more vulns in the IDE section here, then you're better off because you actually are telling the developer right away in a real-time fashion that's very prescriptive and kind of yes or no situation where, here's a vulnerability with what you're writing in your code. Here's an alternative way of doing it. And if you can do a lot of that in the beginning, then there's a good chance that you're going to save a lot of the vulnerabilities that you would have later on in this stage. And it would, take a lot longer to fix because you're already so far along the process. All right, we're almost done. All right, complexity does not always equal risk. So this is something that is true in many fashions, and it is true in this situation as well. Complexity does come with risk, but there are ways to mitigate that and also to actually increase one's security even with more complexity. And the reason I've stated that and kind of showed this picture is you can see that Amazon and Netflix, they do this at massive scale. And these are just simple photos and diagrams, and these probably aren't even all inclusive. But what it's showing is all these little lines are interconnections between all these services that are talking to each other. And then the same thing applies for Amazon here. And the way that some of these individuals are able to actually simplify the complexity is through basically a model of an API gateway or an elastic load balancer, or an application load balancer. And what's happening here is we basically have a choke point. So within security, it's somewhat nice to have a choke point to throttle all of the interactions that occur between all the different things behind my network and everything in front of it. And this choke point here, you can actually add a series of authentication and authorization functions inside of the gateway. You can add a series of kind of checks and balances for network knuckles, network access control things, and all that stuff. You can have this choke point as a place to actually put a lot of and bake a lot of your security into, not a lot of it, but some of it, to help with this whole process of having the complexity, because you're simplifying it into a single choke point where you can actually do a lot of your analysis, monitoring, and things like that. So with that being said, there's another flow here I wanted to show, which is very similar to one there, where you basically have your individuals interacting with your API gateway. That then shoots off to all these different microservices that have databases and basically a message broker. And like I stated, you can have a series of Lambda functions that are baked into this API gateway that are doing authentication, authorization, and certain security checks before it allows it to go into the complexity that is your microservices architecture. Here's just another example shown here where you can see specifically this is a small snippet of what Netflix looks like, because I think this is Netflix. Yeah, Netflix. You can see it down here, Netflix. And specifically what they're showing here is how the complexity is very, very robust back here in the background, but there are some choke points. Like I said, you have the API gateway, you have the load balancer here, you have a series of other choke points here, and this is where you can bake a lot of those functions in for security scanning and also authentication and authorization. All right, we're almost done. So what's next? So this last section of my blog was basically talking about some of the things that were discussed, but they were more future facing. So a lot of the stuff we discussed already are things that are occurring and happening and kind of like somewhat older. This thing is things that are happening today and happening going forward. So first things first, I'll talk about serverless architecture. So serverless architecture is like the next stage or the next phase of cloud computing, where some of my clients actually honestly are starting to utilize this in a fashion where you have your private cloud is traditional, so you own everything. Infrastructure as a service is what most people use today, where they're basically abstracting away. So I no longer need to worry about this because this is the cloud. The cloud's kind of role, and then my responsibility is everything above that. Platform as a service is basically kind of higher level version of that, and then SaaS is basically Gmail, things that you use day to day. But functions of a service is like a new format where you're abstracting away almost everything except for the actual functions, the code that you write. So the beautiful thing about this is many reasons, and I actually think I have a chart in here that explains some of it. Yeah, so here you can see that you're abstracting away basically everything in this first column. You no longer have to worry about anything besides the code. In addition to that, the availability is very high due to the fact that the cloud provider is on that, and that's their job. Additionally, the speed is high because usually they have these things called warm starts, where you're not necessarily starting a machine cold start. And this warm start thing comes with some vulnerabilities where you can actually inject malware and it stays around, but it's a separate topic for a different day. The speed piece is they have these warm starts where you have a machine running at all times, and when you execute the code, it then kicks off, because if you have a cold start from the machine that's off, it takes, I think it's a few seconds or milliseconds longer than it should to actually get that code to execute, so you don't want to add any latency in there. So that's a really interesting piece. Another interesting thing in here is the event-driven piece. So there's this concept called event-driven design or event-driven architecture, and it's really basically a series of functions that have a bunch of events that occur, and if those events occur, these functions kick off. So the entire architecture only is utilized and executed based off of things that are happening on its exterior, as well as interior. And then last is the pay. So depending on how you construct these functions, and if you construct them correctly, you can pay a lot less because you're only paying for what's used. You're not necessarily paying for the resource itself, because even with cloud computing, you still do have to pay for a subset of the time that the machine is running or you're operating on or things like that. You're not necessarily just paying for the code on top of it that's being executed while it's being executed. And then this is the event-driven architecture thing I was mentioning. So if we look at this, you can see back here, these are a bunch of events that are occurring, right? So we have different post requests and get requests that are events that are occurring. We have all of our Lambda functions, or whatever function service you're using, cloud provider. All these functions are kicking off based off of the events that have occurred here. So as this occurs, these functions kick off. They then kick off other functions, and then they go, go to a database to get some data, and then they pull that back to do some other stuff. But the interesting thing about here is, like I stated, is that everything is driven by functions, and everything is event-driven. This is very complex. I've seen some lectures where it just gets crazy with this stuff. Complex meaning like it gets very difficult to do this stuff. All right, man, my throat hurts. Last thing, micro VMs. So micro VMs are kind of the next generation version of containers, where traditionally, I don't know if I have an image for this. I don't have an image for it. So if you don't know much about Docker, there's a book, I think I did a summary on this website. I guess I could draw something that might make sense. So we have traditionally, let's go here. So we have VMs, virtual machines. We have containers, and then we're going to have micro VMs. So traditionally, VMs, when you compare these two together, VMs tend to be more secure because of how they're sandboxed and isolated away from the kernel and a series of other things on the host. So there's some more security here, but they're also slower. With containers, they're known to be a lot faster and a lot lighter weight. So you can put more of these containers on a single host. The issue that comes with this is they're sometimes less secure if done incorrectly. You can make containers secure, almost as secure, maybe as secure as VMs, but you have to be very methodical with mainly the syscalls that are occurring from this container to your host. So if you're able to maintain and kind of hold in that chaos and ensure that each container has kind of a digital footprint or fingerprint of the syscalls that are allowed to use based off of their use, and you can do that through different tools, then this can be secure, but most times it's not. So micro VMs are basically a very lightweight version of a VM that has both the security and the speed that comes with containers. So you're kind of getting the best of both worlds. And these micro VMs are very, very lightweight virtual machines that are kind of bare bones. Everything is ripped out except for what's necessary for the container to run. And you can see here, they kind of give you an understanding of what this looks like. This one here is a container. So this is the container setup here. And let's do black. So this is the container setup where you can see basically everything is shared in this kernel. So this is the host kernel here. And everything is shared between these two containers because we have container 1 and container 2. It says that it's isolated by the namespace. That's not completely true. It's the namespace as well as the C groups, I think it's called, where you can actually divvy up the resources as well as the visibility. But that's kind of the situation there where there's a series of syscalls that are occurring here. Like all these lines would be syscalls and all different types of syscalls. And you have to make sure that you have the right ones, because if you have the wrong ones, an attacker could basically escape this container easily through a syscall into maybe a Docker daemon and then up into something else. But with the micro VMs, and I think Kata is one of the providers, is you can see that they're isolated off from each other, similar to a VM would be. They have separate kernel spaces, so they're not actually interacting with each other. So this helps prevent containers talking to each other when they shouldn't be, and also it prevents the escaping mechanism. It makes it more difficult. That's that. And then Firecracker is a micro VM. So this is something that people have used. It's one of the more popular micro VMs. With that being said, this was a very long video. My throat hurts, and I hope this was useful. So this was my process. This is what I learned, all that stuff. So I will see you in a little bit.